Hello, I'm Ron Miller and I'm here at Optus Corporation in Toronto, and today we're going to demonstrate some gaming chip RFID. It's HF 13.56 megahertz. Last year I showed jamming of PGM technology, which was 18,000 mode 3. Today I'm going to show some stackability, and also we have a simulated section of a blackjack table with two positions. And we'll see jamming as applied to the blackjack table, which will improve its performance. Some of the hardware has been updated from what was used 6 years ago to build blackjack tables and mini baccarat tables. So first we're going to look at the stackability using a network analyzer. Here we are at the network analyzer. The horizontal range is 5 megahertz to 30 megahertz, and I'm on 5 dBs per square, and looking at how to test chips for resonance, and I'm going to show you how stackability works. So first of all, I've got a standard 15693 DVD circular sort of inlay here, and it's attached to DVD, and that's what its resonance looks like. 13.56 is sort of in the middle over there. Now when you put two of them together, you're going to see what happens. And you see you get these extra frequency dips. So extra resonances appear, and this is a phenomena called resonance splitting. How far apart they are depends on the coupling factor between them. So when you have chips, I'll show you a chip. It's tuned at a different frequency, and it's way up over there. The exact frequency is described in my patent. So we start to add chips to this, and you see more of these resonance peaks appear. Add a few more, and we'll be brave, take a whole pile of 25 of them. Let's see what happens. And you get all these resonant peaks, but you do get something at 13.56. So this is why you can read a stack of chips. This is why they're stackable, because they're tuned way up there. This is a picture of a 7-player blackjack layout from a casino. The side bets are the circles and the main bets are the squares. Okay, this is an overview of the simulated section of a blackjack table. It shows two betting positions. Position number 1 and position number 2, and they are 10 inches apart, 4-inch diameter, and beside these two positions is a place for a side bet. This one is implemented with antennas. This one isn't. This is a little field strength indicator that tells us when the read field is on. And coming over here to the equipment, there's a multiplexer to route the reader to the various antennas on the table, and a jammer to send signals to the jamming antennas, and a little manual control over here to control these without lots of layers of software to run the demo, and a laptop. And a FAG reader underneath, which we can't really see, but maybe you can take a shot of that. So I'm going to show you how the gaming chip is made. This is a dummy, so these are dummy blanks, plastic, from Chipco originally. They're 39 millimeter diameter, 3.3 millimeter thickness, about 10 grams. So they've been machined out to accept the circuit board inlay, and I'll show you what that is over here. So if you look at that closely, there's a spiral track and a chip, and that's it. So this is the hardware underneath the tabletop. This is a reader antenna, and it's 6-inch diameter, shielded. It's got some interesting features in it. In the center of it is a pattern just like an inlay, and there would be a chip in there, and that would give the antenna an ID number. So when you're reading this antenna, you'll also get this chip here, and that will tell you all the chips that the antenna is read with is associated with this particular antenna. This is a little pickup loop, so the antenna's got the capability of measuring its own levels. In the completed board, there would be a microprocessor and some relays that will do auto tuning, and also a relay in here that opens up this loop when you want to stop it from reading. Down below is the L-shaped jammer. So it's got an L pattern. The reason for the L pattern is you want to block chips that are sitting over there, and also player chips that would be out over here. The feature of this one is that there are two loops, and it can be switched back and forth if you need to get closer to this side or closer to that side. Here's another position 1 read antenna. This one is installed with a relay, and I've taken over the microprocessor control for it and just put some manual switching in it so I can turn it on and off. Lying up right above there is about 1.5 inch sidebit read antenna, and underneath the sidebit read antenna is a jamming loop, which is underneath, and it's an oval. It's about like that. And if we come off the tabletop onto the electronics, this one is a 128 multiplexer, normally microprocessor controlled. I've just got some manual wires to control it from some switches, and it's fed RF signal coming down up from the reader, which is a FEI LR reader. Beside it is the jammer. There are 5 usable output ports from this jammer. It gives a variety of jam signals. This is going out here. This is one type of signal, and this one is coming into this circuit over here. It's another type of signal. It's just for experimental purposes. Both types of signals will work. They're high impedance antennas. They are not resonant. The signal levels for jamming are very low in comparison to the signal levels for reading. So the first test is to show how the multiplexer sends the reader signal to the various reader zones. So we have zone number 2, number 1, and you'll see also that the sidebit is picking up some of the signal by induction from position number 1. Here's a sidebit by itself. We can turn off the antenna on position 1 so you read only the sidebit. You can see that one go on and off. And you can turn this one back on again, and you'll see position number 1. I can turn them all on. So I think you can see all the indicators coming on. So I'm the computer who is running the multiplexer. Okay, start with 1. So here's 1 chip. Here's 2 chips. 5 chips. We're going to take the 5 chips, we're going to move them around to see the read zone. So we can read anywhere over here, and basically touching the green circle. Go a little bit further away, like ½ inch away, stops reading, more or less. And then we're back inside. There was a question of how many chips we could read at the same time. So here we're showing a pile of chips in the bedding circle, and we have 65 chips shown there. And if you zoom in on the screen, we think we can get the chip count to show up. And now we're reading 65 chips. So the next test is to show that NXP and EM micro transponders work interchangeably. They're 15693 standard, so showing on the screen we're reading them with no problem. They can be intermixed. All right, so here's a stack of 25 chips. And you can hear it beep. 5 chips on position number 2, and it's reading on the screen 5 chips. Okay, now we'll put 5 chips on position number 1. Total read is 9 or 10. That's because the field that is over here is coming over to pick up and induce into position number 1. So this is the cross-read problem that you will see on some tables. Now the way around that is the following. Ready? So what I've done is I've opened up the antenna loop on position number 1. So we go back to reading only the chips on position number 2. So position number 1 needs a scheme to detune its loop while you're reading position number 2. So here we are reading 5 chips in position number 2. I'm going to put 5 more chips right in the middle. And you can see we're going to read 10 chips. You get the same effect if you have a pile of chips sitting down here where players like to pile up all their chips. Now, the solution to this is to add on the jamming. So we're going to do that. We switch on the jamming loop. So you see, with the jamming turned on, all the players' chips sitting over here are no longer red. Okay, take them away. Similarly, with the jamming loop on, chips in the middle are no longer red. Okay. Now, there's the questioning loop jams the reader or the chips. So we're going to show you the jamming loop. Take this off. So here's the jammer. Take it out. Put the top back on. Pile up the chips. Okay. Reading 10 again. I'm going to hold the jammer in my hand. I'm going to place it over the chips. And you'll see what happens. Okay, so I've got the jammer antenna in my hand, and on the screen we can see it's not jamming at this point. I'm just going to lower it, and it starts to jam the chips. There it is. Now, to show that this is not jamming the receiver, I'll use the same distance on this side, and you'll see there's no effect on reading the chips. So this shows that the jamming signal is affecting the chips only and not the read channel. Okay, so we've placed 5 chips as a main bet and 5 chips as a side bet. And the objective is to read the main bet and to read the side bet and not mix them up. So if we look at what's going to happen, first we're going to read the main bet, and we have 10. Now we're going to read the side bet, and we have 5. Then we'll go back and we're going to read the main bet again. Reads 10. Now if I turn the jammer on, which will eliminate the side bet chips from responding, so we should read 5. Turn the jammer off, we'll go back and read 10. For additional information or comments, you may contact me at